Welcome to Virtual Laboratory. I am Professor Uttam. Today I will discuss about two types of flow system, that is laminar flow and turbulent flow, and how it is defined according to Reynolds experiment that also will be displayed. In the flow through a pipeline or any flow over a flat plate or any conduit, you will find three types of flow system which can be distinctly divided into two parts. One is laminar flow, another is turbulent flow, and in between the flow pattern is called buffer flow. So here you will see that laminar flow or streamline flow and turbulent flow, these two are shown here. In the laminar flow, the layers of the fluid moves almost parallel to each other, whereas in turbulent flow the layers are not parallel but wavy and even with circular eddies. Now we'll show you that the unique number which is called Reynolds number, which is very important for pipeline design and fluid flow system, which is NRE. Here you can see that is written as dV rho by mu, where d is the diameter, v is the average velocity of the fluid flowing through the pipeline, and rho is the density of the liquid or gas, and mu is the viscosity, as we have already seen earlier in our experiment for measurement. Now see that NRE, which is Reynolds number for a laminar flow, will persist as long as it is less than or equal to 2100, and if Reynolds number is greater than 10,000, it is turbulent, whereas Reynolds number in between 2100 and 10,000, then it is a buffer flow. So we have three distinct types of flow system in a pipeline. For this applicable for pipeline only, where Reynolds number is a unique number which is utilized for determining this. This can be experimentally verified, and next we will go to the experiment, to the virtual experiment obviously, and let us see how we can determine these values. Now we enter our virtual plant. This is our virtual plant. This indicates a Reynolds experiment. You will find a glass tank, which is a large glass tank, and inside this immersed a pipe, which is a glass pipe, having a funnel type input, where a ink bottle is connected through a glass rod. This glass pipe, narrow glass pipe, which just inject the ink. It is just like a thread, it will come as the stopper is open, and there is a valve. This water exits from this narrow pipeline, and is a exit valve or drain valve, which can be opened as soon as it is started, and then you can increase or decrease the flow rate and see how this pipe for this flow rate is, what is the value of the flow rate is calculated, velocity that you have to determine from the flow rate and the cross-sectional area based on the diameter of the pipe, and Reynolds number is also determined from the density, viscosity, and the pipe diameter. We'll see that how this Reynolds number changes the pattern of flows. Let us start. So it's a starting point where the drain valve is crack open. You will see the thread of blue line is flowing through this pipeline, Now there is no ripples, liquid is uniformly moving, that is a laminar flow, and you will see that velocity very low and Reynolds number is also low, only on 27. Now we'll increase the velocity gradually. See, it is still like a thread, that is laminar flow persists, and the Reynolds number is 500 plus. It is still laminar flow is continued 11,000, 1100, 1400, 1500, 1600. We are nearing to 100. Now it is, see that it has crossed 2100, slightly increased, and as a result the flow has been disturbed. You see there will be ripples, and because of that the thickness increases for the ink, and now you go on increasing till 10,000 and look at the flow pattern. See that it is still not separated, but the thickness is increasing gradually, indicating there is some ripples. So I am going quickly for increasing the Reynolds number, and observe that flow is changing, velocity is changing, Reynolds number is changing. So you will find that it is much thickened, indicating too much of disturbance. And finally you will find the turbulent flow when the pipe will be filled with the ink. So there will be much more eddies and mixing as soon as it reaches 10,000. So it is gradually increasing thickness, and Reynolds number is approaching 10,000. So these are all buffer. As soon as it is 10,000 or slightly above, there will be vigorously turbulent and mixing will take place. So we are still in the buffer, very near to turbulent zone. Now it is completely turbulent, and the ink is thoroughly distributed throughout the pipe cross section, indicating that there is eddies and form frictions, and as a result this Reynolds number is indicating it is a highly turbulent flow. So that's a experiment. You can do it in your laboratory if you have not done. This is just a simple understanding of the Reynolds experiment, and which approves the Reynolds number up to 2100, as I already told you, is laminar, and after that it is buffer, and when it reaches 10,000 and above, it is totally turbulent, where eddies are formed, and finally the ink is mixed up. And so if you want to repeat the experiment, you have to stop the application here and you have to restart it. Thank you very much for observing this video.